Welcome to the channel. We are discussing Tower of Hanoi problem. In the Tower of Hanoi, while moving the discs, sometimes we feel like we have choices. For example, here in this step, we can move disc 1 to helper rod as well as disc 1 to source rod. Both are legal moves. At many steps in Tower of Hanoi, there are multiple legal moves available, but only some choices keep you on the correct solution path. So, how do we know which legal move is the right one among the several legal options? To choose valid legal moves, we can use mathematical formulas. Today in this tutorial, let's talk about that. So, if number of disc is odd number, then we know the first move. We need to move disc 1 from source to destination. If number of disc is even number, then first move is move disc 1 from source to helper rod. Next, for other moves, here for odd number of discs, we'll perform step modulo 3 operation. If result is 0, then the move is between helper and destination. H is for helper, D is for destination, S is for source. Then if step modulo 3 is equal to 1, then move is between S and D, source and destination. When I say move between source and destination, it is the legal move. It can be from source to destination or destination to source. Legal move is the move which follows all the rules of Tower of Hanoi problem. Then if step modulo 3 is 2, then move is between S and H, source and helper rod. For even number of discs, step modulo 3 is H and D. When step modulo 3 is equal to 1, source and helper rod. Step modulo 3 equal to 2, source and destination. Now the problem is how to remember this. No need to explicitly remember this. What you can do is, for odd number of discs, just take 3 discs. First write down 3 steps. Step 1, step 2, step 3. Here because it contains odd number of discs, we know first step, that is move disc 1 from source to destination. If we use step modulo 3 here, that is 1 modulo 3, so we'll get 1. So move is between source and destination. We got the first result. Next, for step 2, we can move disc 1 as well as disc 2. But if you move disc 1 to helper rod, that is of no use, because in the previous step, we moved disc 1 from source to destination. If you want to move from source to helper, we could have done that in the previous step. So no need to move disc 1 to helper rod. If I move disc 1 to source rod, we are undoing the previous step. So we can't do that. So only one option is left for us. That is move disc 2 to helper rod, right? That is step 2, 2 modulo 3. So we'll get result as 2. When step modulo 3 is equal to 2, then move is between source and helper rod. So S and H. So here you can see when 1 source and destination, 2 source and helper rod. And for last step 3, okay, now here you can see we can move disc 1 to helper rod as well as source rod. Both are legal moves, but if I move disc 1 to source rod, there is no use. But if I move disc 1 to helper rod, then destination will be empty. We can move larger disc, that is disc 3 to destination. So that's why we need to move this disc 1 to helper rod. You just need to remember first 3 steps, okay? So here, when step is 3 modulo 3, we'll get 0. So at that time, the movement is between destination and helper. If you confused about this step, don't worry. We have only 3 rods, right? In the first 2 cases, it covers the move between source and destination as well as source and helper rod. Only one move is left, that is between helper rod and destination rod. That is when step modulo 3 is equal to 0. Okay? This is when number of disc is odd. What about even? It is very simple. You can take example of 2 discs. First step, 2 is even number. So we need to move source to helper. 1 modulo 3 is equal to 1. That is step modulo 3 equal to 1. Move is between source and helper rod. Then for next, we'll move source to destination, right? Look, our main aim is to move all the discs from source rod to destination rod in the same order. So for that, first we need to move the larger disk from source to destination. For that, first we need to free up that disk. That means we need to remove all the disk above that from that rod. So here now disk 2 is free. We can move that to destination. So I'll do that. 2 modulo 3 is equal to 2. That is when step modulo 3 is equal to 2. Move is between source and destination. Then step 3, last step. Only one disk is present. Move that to destination and we are done, right? So here last move is between helper and destination when step modulo 3 is equal to 0. You just need to remember these 3 cases. Okay, so this is how we can calculate these moves. In the next tutorial, I'll show you how to use this move and calculate every step and solve the problem. So that's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I'll meet you in next class. Till then, take care.